your seats. If you're seated in the back, somebody said ask them to move forward so they can see the visuals better. But I know every time you do that to an audience, they don't move forward. You're where you want to be, you're comfortable. But if you find out that you can't see the screen, then you can move forward on your own initiative. But good evening. Good evening. Good evening. I'm Doug Fromm, and I'm a resident of Orleans, and I'm president of Orleans CAN, which is a newly formed citizens group to work for clean and healthy waters in Orleans for future generations. That's our vision. And part of our mission is to provide factual information in support of implementing the CWMP voted for in 2008. On behalf of Orleans CAN and the Orleans Pond Coalition, I offer a hearty welcome to each and all of you this evening. We're pleased to have the Orleans Pond Coalition join with us this evening in sponsoring 3 forums, Ask the Experts. And tonight we will ask the experts focusing on Namskaket Marsh. We have a distinguished panel of scientists with us. They'll be introduced shortly. The format of the evening is as follows. The panelists will offer about 30 to 40 minutes presentation. And following their presentations, we'll open for your questions. Questions seeking understanding to clear up confusion. And if there's one thing I hear as I go about the town, it's, I'm so confused. And so our goal tonight is to help unpack some of that confusion and to bring clarification. The other I hear is, I don't understand because there seems to be conflicting information. So we hope we can give you a little clarity on that as well. Some of the confusion and maybe some of the misinformation seems to give rise to concerns and in some cases even fears regarding what it would mean to move forward implementing the CWMP. We ask that when you ask a question, when we get to that part of the evening, that you begin by stating your name. I emphasize that this is a night of questions and answers. It will not be a time for speeches or arguments. Okay, when you're ready to ask a question, just put your hand up and a microphone will be brought to you and you can state your name and ask the question. That brings me to just a few ground rules for our time together. Our time together will be a time of civility and respect. We will honor the practice of one person speaking at a time. We will honor the practice of raising a hand to be recognized, and if there are multiple hands, the moderator will recognize you in turn. We ask that you limit questions to about 1 minute so that not to monopolize the time when someone else might be waiting to ask a question. And then if you want to ask follow-up questions, of course you can do that. So with that format, let's begin. And I'm pleased to introduce our moderator, Rich Delaney, who will introduce the panel. But I'm going to ask you to first give them a round of applause of welcome here tonight.
Well, thank you very much, Doug, and good evening to all of you. Thank you for your interest and for your taking time to learn more about the exhilarating topic of wastewater. It's one that's been on a lot of our minds for a long time. I know some of you in the audience have been thinking and learning about this issue within our town for years. Some may be new to the issue tonight. But either way, I think you'll find this will be a productive evening with lots of good information, and hopefully we will all leave here with a better understanding of the science that underlies the decisions that we're about to make. We do have an outstanding panel. You see their names in the agenda, and I'll introduce them just briefly in a minute. But I'd like to start the evening just by setting a little bit of context, especially for those who have not followed this issue too closely. We have, as a town, been at this or working up toward a decision about how we are going to deal with wastewater for quite a few years, maybe a decade now. I think there's a strong growing consensus. I really do. And I think there's a strong consensus about the fact that we all acknowledge there is a serious problem that must be dealt with. I think that's clear. I believe most people understand this problem is not going away. We cannot ignore it. We must take some action, one way or the other. We also, I think, as a community, now have reached a strong consensus on the fact and understand it's not going to be one decision. We will be making a series of decisions over the coming months and years, and even another generation behind us perhaps, that will continue to bring us to a solution. And that's basically what we call adaptive management. We will make a decision, we'll see how it impacts, we'll adjust and keep on going forward. I think we also have a strong consensus that we are not in this alone as a community. You know, most towns on Cape Cod are dealing with this just as we are. And in fact, it's not a town-by-town issue, it's a Cape-wide issue. Watersheds cut across towns, so there are regional efforts that are needed, and I think we're beginning to understand that an institution like the Cape Cod Commission can play a role in helping us see the benefits of cooperation within watersheds when it is appropriate. And also, I believe there's a much deeper appreciation of, as a community, of the role of science, and that's our focus tonight. A good science-based discussion is what will inform a wise management decision that will get us to a cost-effective and practical solution for wastewater. So I'd like to think of this and have you think about tonight as a science-informed community dialogue. We're the community, we've got an issue in front of us, we've acknowledged it, there's a problem, we know we have to get to yes, we've been working in that direction for a while. We know the knowledge this panel has is going to help us inform that decision, and it has to come about because of a community dialogue. That's what tonight's about, and that's why I'm pleased you are that you're all here. This science can sometimes be complex, sometimes it can be challenging, and one of the weaknesses perhaps, despite all of the consensus building and getting to yes that we've done so far, I think in this particular area, the science, we have had the most amount of confusion, misinformation, picking bits and pieces of the science to justify a point, and someone else uses the same information, so it gets to be an obstacle for us. Tonight, we will all hear, no matter where you are in the process of learning about wastewater, or what you think the favorite solution will be, we will all hear the same answer at the same time to all of your questions, and hopefully that's where we'll build some more consensus from the science. So, what can you expect from us? Well, you can expect from this group direct access. Your questions will go right to the experts through me. I'll be moderating. Please trust me. You know, make sure they get to the right person. You can expect clear, objective, concise answers from the panelists. And I think you can expect to leave here better informed. What I would like to expect from the audience and what the panelists deserved is your open-mindedness. Listen to all of the answers, put all of the pieces together, all of the perspectives. Resist the notion or just resist cherry picking, I should say. Listening for the answer you want that supports something you may have already decided. Let's start from an open slate and see if we can all get to the same place together. And of course, as Doug has suggested, let's conduct ourselves in clear, concise, courteous, respectful language. So, with that, I'm going to ask, I'll just introduce them quickly. You have, as our first two speakers, Ed Eigner and Brian Howes, PhD, both from the University of Massachusetts at Dartmouth, the CMAS program. Following them will be Peter Weiskell, Dr. Peter Weiskell, PhD from the U.S. Geological Survey. Tara Nye is doing work with the Association to Protect Cape Cod. Dr. Amy Costa is with me at the Provincetown Center for Coastal Studies, and Brian Dudley is with the Massachusetts Department of Environmental Protection. And together there will be a presentation working this way, down the table with Brian doing the wrap-up. That will take approximately 30 minutes, and I'm going to allow about an hour. Hopefully that will, for questions, Q&A, and we'll go longer if people need to. But at this point, could we have the lights dimmed up front? If you still can't see, don't hesitate to move up during the process, and I'll turn the microphone over to Ed. And would you, the panelists, like to speak from where you are? Is that the easiest thing?
Yeah.
Okay. Go ahead, Ed, please.
Thank you. Next slide. What we're going to talk about today is we're going to talk about a summary of sort of the high points of the details of all of the studies that have been done. There has been a lot of information that's been gathered on this system, Namskaket Marsh. Tremendous amounts of very robust evaluation of the system. But we're really going to try to hit the highlights, the important key decision points that will hopefully reiterate a lot of what we've already talked about. And when I say already talked about, I think, at least for me and Brian, this is probably about the 5th or 6th talk on the same system that we've done in this town. So we're going to reiterate a lot of the same points, and certainly we're here to answer your questions, but I want to stress that discussion, we've had this discussion a number of times. First, to start off, really want to sort of orient and make sure that we're all sort of in the same spot when we're talking about this. This is the whole Namskaket Marsh system, all the way down into here. We often call this little area down here the pocket marsh. Tri-Town, the Tri-Town site's right over here. Rail trail runs up there. Hurley's Bog is a small area that's on the other side of the south of the rail trail, and what we call the Radio Tower Marsh, which is actually right on the Brewster-Orleans line. So the Brewster-Orleans line runs up through this marsh. Next one. This is the same map, zoomed in on the key area. This is that pocket marsh, the Tri-Towns facility, the rail trail, Hurley's Bog, and then again the Radio Tower Marsh. We're going to start off by talking about the Massachusetts Estuaries analysis assessment of Namskaket Marsh. This is the most comprehensive assessment that's been done of the system, most recent certainly. It brings together a whole lot of different information about characterizing the system, what sort of impacts occur in the system. The basic idea in this assessment is to see how much nitrogen the system can have without unduly impacting the marsh. So how much is safe? How much nitrogen is safe for this marsh? So when we go through, and just like all of the other Massachusetts Estuaries project assessments, we go through a series of steps, a series of assessments of key portions of the system. And they're listed here. So go through and do a watershed delineation, nitrogen loading assessment of that watershed. So we develop a nitrogen load coming from the watershed. If there is a stream, and in this particular case there is, we go through and we measure that system, the stream flow, for at least a year. That's multiple measurements throughout the whole year of the nitrogen coming through that system, the freshwater flow that's coming in through that stream. We get tidal measurements and bathymetry within the marsh system. So we're looking at the shape and the bathymetry of the stream, the size of the marsh plain. Sediment cores for doing an evaluation of the nitrogen being regenerated out of the sediments. Look at the benthic animal community. In this system, there were 3 long-term water quality monitoring stations, and then we develop a model that is calibrated and validated so that we can go through and do predictive activities. So we develop a model that's of existing conditions, and then once you have it very well constrained in terms of the existing conditions, then you can go through and say, well, what if we change things, like what if we add a significant wastewater treatment plant within this watershed? Now that's just the overview. We're going to talk in detail about a lot of these things. First thing to start off with is the watershed. This is the watershed to the whole system. This is that stream coming in through the radio tower Marsh. The rest of the watershed, direct watershed, groundwater watershed. And you'll notice that it feeds, the watershed feeds up into and intersects some ponds that are over in Brewster. So the water flows from these ponds into the stream watershed and then into the marsh. And you'll notice that some of these pond areas actually discharge outside, so they're shared watersheds. The ponds, some of them go outside of the watershed, some of them discharge inside the watershed. One of the key points down here, hopefully all of you can see it, is we get this watershed delineation from the U.S. Geological Survey. It's based on a regional groundwater model. That model is, again, goes through the steps of calibration and validation. It's a collection of all of the water table and subsurface information that's been gathered up until that time that was done. One of the things that we have in this model is we can also, aside from doing pond watersheds, we can also do the stream watersheds. And in this particular case, we also have the measurements that were done this is at that radio tower Marsh. And we came up with, where is it? There it is. A flow based on the groundwater modeling of 4499 cubic meters per day. Now, 2 years worth of monitoring, the average flow was 4,050 cubic meters per day. It's a very good validation. So the measurements and the groundwater model put together actually fit. And that's what we're trying to get when we go through this whole process, is to make sure that what we actually measure in the field matches up with what we have come out with from the models. The next one's yours. Nope. After we've gotten the watershed information all put together, we're going to come up with a nitrogen loading model for what's occurring, all the nitrogen sources within the watershed. And when we do that, we go and we look at each individual parcel within that watershed. We come up with a representation of how much wastewater is generated on each individual parcel based on the water use on each parcel. We look at the average lawn sizes, road runoff, all of that information is put together. And then we'll look at key features that are somewhat unique to the watershed. In this particular case, the Tri-Town plant is in the watershed. That's a key feature. We want to look at that. We had 2004 to 2006. This is the wastewater discharge at that site. This is each of the months. So you can see 2004, 2005, 2006, pretty consistent for those 3 years. We also look at the nitrogen load based on those flows. Again, relatively consistent. I think we came up with an average nitrogen contribution coming out of that site of around 1,200 kilograms per year. Now that's what's being discharged to the ground. That's not necessarily what's making it to the marsh. And you're on.
Okay. We take that water quality, or that nitrogen loading data, and what I'm going to talk about now is we then put that in and build the water quality model for this system. But I would like to say that even without the water quality model for this system, we can still do everything and come to all of the conclusions that we come to with it. It's a little bit more refined with the model. There's some vagaries about salt marshes that are greatly helped by the model, but you don't need it. And the reason I say that is I always find it somewhat comforting if you can just look at the basic principles of the data that's available to you and on your own put it together, and it comes out pretty much the same within 10% or so, 15%. So that's the critical thing. And that pervades this entire talk that we have. These are the 3 water quality monitoring sites that we have multi-year data for Namskaket. This site up here is right by radio tower discharge. It's a stream site. And then we have this site which is in the central marsh, which is right where the creek breaks out and starts developing open water areas in addition to just a straight channelized creek. And then this lower area down in here. The reason that these are important is because this ended up being mainly a freshwater site coming out of Radio Tower Marsh. And remember, we did this before the weir was in place. All this data was collected prior to that. This has been since 2007 or so. So what we did was, this data isn't 2007, it's 2000 through 2005. But what we have here is something which is right up near the headwaters, something right in the middle, more representative of the bulk of the marsh, and then something right down near Cape Cod Bay, which is out here, which is strongly influenced by the low nitrogen waters and the high salinity waters at Cape Cod Bay. And then this is just a table out of the report. The one thing that you're going to see in a second is when you look at these model averages, you're always going to see that the model average, I hear this, I'm jumping ahead to what I always get asked, so I'm going to try and kill it here. There's a reason why the model average is different from the measurement data in this system and every other estuary in southeastern Massachusetts. And the reason is when the tide comes in, it fills this pretty much empty marsh with Cape Cod Bay water, which is very saline and very low in nitrogen. But when the water leaves the marsh, it's not like like a Cape Cod Bay, or it's not like Town Cove or Pleasant Bay. When the water leaves the marsh, there's pretty much only a trickle of water left in those marsh creeks. And so what happens is that you're pretty much walking almost on fresh water or brackish water at that point in time. And so the nitrogen concentrations go way up, the salinity goes right down. And people always say, that doesn't make sense, how can it be, why is there so difference? And the answer is, when we model it, we can correct for the tidal thing and get the true average by doing a time step through the model that just allows us to do math. If we just take the water quality data, it's not going to match up with the average, it's going to match up much closer to the maximum, because these data were taken very close to low tide, okay? When the water's low, salinity's low, nitrogen's high. And here's some of that salinity data. This is the salinity map of the marsh, and what you see, and the reason I put this up is a bunch of reasons, but one of them is that salinity will be part of our discussion later on. And there's a salinity gradient in all estuaries. There's a strong salinity gradient in this one, where you're getting, around 30 out in Cape Cod Bay or so, and by the time you get up into the upper marsh, into the little pocket marsh, where the triton's right about there, so in this little pocket marsh, you're down in the 10 to 15 parts per thousand. So you already diluted the system almost 1/3 of seawater. And this is the average concentration. If you look at the individual ones, like in the center of the marsh right there, you'll see this very large range in what happens in nature. And this is the measurement data. And as you can see, that's let's see, yeah, that's high tide. And so therefore what we have is we have this average salinity here. What you see way up in Radio Tower Marsh at low tide, what comes out of Radio Tower Marsh is fresh water. As a matter of fact, the average of the water quality data was about 6.6 parts per thousand then. And but when the water went in, this is before the weir went in, the water still would get up into the marsh pretty well. And what you'd see is you would, at that site, which is at the mouth of that marsh, you would see salinities would go up to 25, which is the main marsh salinity up in here. And out by the bay, you have a much smaller range with the tide, and so what you have is, again, near high tide, when the water's coming in, you'll get higher salinities. Okay, next. More importantly, though, the nitrogen values change as well, and at low tide, what we see is nitrogen values are quite high, and that in each of the sites, this is just a one-to-one plot to see how well the measured, which is on the x-axis, this axis here, and this is the predicted, and the measured and predicted work really well. I hate to tell you, but if they didn't work really well, we'd be showing the slide, not because we wouldn't show you, but because it would mean there's something wrong and we'd have to tear the whole thing down and do it until we get it right. We don't change anything for this. The models are set up and they're calibrated using salinity because it's a way of measuring the dispersion. You don't need to know what that is, but it's one thing that you can't take out of a table in a book, but we can measure it with salinity. Once that goes into the model, then this nitrogen prediction, the predicted values here versus the measured values down there, are just run based on the load coming in from the watershed loading model, the regeneration in the marsh, atmospheric deposition, and the tidal flows. And there's nothing else. There's no tuning. So it has to work. It always pretty much works if the model is parameterized and constructed properly. If it's not, and there's an error, it doesn't work. And that's usually how the world goes for us. The critical thing here is at low tide, you see these very high nitrogen concentrations, and that's because the salinity is quite low. And I'll just tell you, walk out to Namskaket Marsh, don't take my word for it. Take the tide chart, check it in the local paper. Go out, look in the marsh at low tide, and there won't be more than a couple inches of water in the mid station and the uppermost station of marsh. If you jump down into the creek, which could be quite dangerous, considering some of these creeks are 8 feet deep, but if you succeed in getting down there, what you'll see, if you check the water, is very, very fresh. And I'm going to drive that home over and over again. It's very, very fresh. It's not very, very fresh because of Tri-Town, and it's not even very, very fresh because there's a new wastewater treatment plant out there, because there isn't. It's very, very fresh because that is the construct of salt marshes on Cape Cod. Every salt marsh is like that. All right, I have to talk a little bit just to throw up for the, we have to set a threshold for what is the tolerance level of a wetland, in this particular site-specific wetland, for additional nitrogen loads. What is its status today, and what is its health going to be in the future? And most of the time in the systems we look at, they're way beyond their ability to tolerate nitrogen, that we have to lower the load. This particular system, as most of the salt marshes on the Cape, are actually able to tolerate more nitrogen going into them. And the reason is that salt marshes, unlike bays and harbors, drain out at low tide, as I said. They also, most of the ecology in the marsh is on the vegetated marsh plain, which is in the air for 12 to 18 hours a day. It's exposed to the atmosphere, so it's very hard to make that go anoxic at the surface. And the system is also evolved for this type of environment. And so most of the time for the Estuaries project, and most of what you hear about Pleasant Bay, about Nauset, Town Cove, that what you see is us talking about that, that geez, the system has got too much nitrogen in it, too much organic matter in it, and it has low oxygen, and it's lost its animals, etc. We have to bring that back. The thing with salt marshes is that if you look back, all the way back to the 70s, you'll read in almost every research journal on marshes, salt marshes are naturally organic matter and nutrient rich, and therefore can serve as nursery grounds to the adjacent estuary because they're so productive. But they're naturally that way. So that's why they have a higher tolerance. If you look at these graphs here, which some people do, and they write me and say, well, geez, there's low oxygen in here, it gets down to, you know, the individual points, let's say 3 milligrams per liter. That's pretty bad for a bay. If that was a bay, wouldn't that be bad? The answer would be, yeah, it would. But it would be bad because that would be a bay where things aren't adapted to that. These systems are adapted to this, and the animals that live there, which are, we did an animal survey up in these blue dots here, the animals that live there are still the communities are very productive, with hundreds of organisms per very small, it's only 0.018 meters squared, it's about this big. There's hundreds of animals per that size of surface of those creek bottoms. They're very productive. The species that are there are not indicative of like sewage sludge or high organic, or even areas that the animals are stressed and die. Town Cove, for instance, is. The upper part of Town Cove, there's either nothing living there, or the organisms that live there, because it also has this very low oxygen. That system is not developed that way, and the organisms you see are the same organisms that were first described from the sludge dumping of treated sewage sludge in New York Bight. So there's a lot known about the natural history. The natural history, the productivity of these communities say this system is good. The oxygen levels there are actually pretty good because we've studied a lot of marshes that there isn't a single house for 7 or 8 miles. And it goes anoxic every night. And it goes anoxic every night because it's naturally that way. So that's part of our thinking on Namskaket. You can't just look at an estuary and say, well, a marsh is an estuary. It's part of an estuary. It's not an estuary. You have to look at the system as a salt marsh is what it is. It is not any of the others. So finally, and this is in the MEP report, but basically we look at all of these things as health indicators for every system that the Estuaries project does. We look at the oxygen, we look at chlorophyll levels for phytoplankton blooms. We look at macroalgae, which are those drift algae that float around in bays. You find them on the beach. We look at eelgrass. Marshes typically do not support eelgrass, so there's none in here, so it's not a receptor. And we look at the animals that live there, all as indicators of what's going on. The critical stress indicator for salt marshes in this region is large accumulations of macroalgae. That's the one thing that we typically will see in systems that are somewhat stressed. And there are some that are stressed in the region, but for the most part, they're pretty good. And the other indicators, you'll find that the chlorophyll levels are very low in Namskaket because the water only stays there for 6 hours or 5 hours and then goes back out into Cape Cod Bay. You just can't grow a lot of phytoplankton in a couple hours. All right. So then, after we did that, and we set this sort of threshold kind of concept that this system is below its limit, where it would be, in other words, it can tolerate more nitrogen inputs, and we sort of determined what that was. In fact, we determined that at this station here, which is sort of the best station because it's not just pure fresh water coming in and it's not influenced strongly by Cape Cod Bay, that what we had was, as long as the nitrogen concentrations at that site never rise above 1 milligram per liter on average, and right now they're running, I think, at about 0.6 or something like that. But as long as they don't go above 1, then what that would mean is at the point that becomes 1, then the upper marsh becomes over 2, and 2 is not good. And so, in fact, what we're trying to do is keep this whole system in here between 1 and 2, which is developed based on looking at other wetlands in the region, looking at this wetland specifically, and looking at wetlands around the world in terms of their nitrogen levels. After we did that, though, and that's up here, these are then we can go back from the concentration and we can develop the actual loads that the watershed would have to go to. These are the present loads into the system in kilograms per day for the Marsh watershed and then those other watersheds that Ed showed. And what you see is that at build out in this system, nitrogen level loads will triple almost 2.5 times, but it'll still keep it below the threshold load for this system. I want to go one more thing, and that is that for the main load here, which is the proposed load or the potential load coming from a new treatment system, it's the numbers that we were given were 500,000 gallons a day being discharged on average, at 3 milligrams per liter. And we can calculate a load for that, how many kilograms that is a year. And so we did that, and we were able then to push that load on top of the existing load circuit and see if we went over the limit. And we don't. In fact, that load is in these loads here. In these loads here. It's not pushing it over the limit for 2 reasons. One is, well, for one reason really, the system has a lot of freeboard. It can tolerate a lot more. But the other piece is, and nobody seems to ever talk about that, if you get rid of Tri-Town, you get rid of 1,200 kilos a day. If you put in this new treatment plant, it only puts in like 2,100 kilos a day. So it's not like you're putting in 2,100 kilos a day, you're putting in a net increase of 900 kilos a day, which is like a 1.7 or 1.8 fold increase. Well, that could still be a lot. But the other piece of the story is that the build out in the system is mainly from commercial in areas. But in build out, the load is going to go up thousands of kilos if it happens. It's still a potential. Build out is a potential. We got the numbers from the planning department and as well as Cape Cod Commission. But the much bigger nitrogen load to this system will come from commercial and residential, mainly commercial, than would ever be what came out of that treatment plant, even if the whole treatment plant discharges to the marsh. And that's here. I mean, the critical thing is that when we add this in, we get that number. It's now 9. It goes to 15. It also, there's a little bit of an extra residential housing and such. But the total is still well below the threshold of 45, and it still only brings the total up to 31. And it keeps the the concentration here well below 1 at about 0.8, 0.78, something like that. So it stays way below. We have still a lot of freeboard. The good thing about freeboard, the good thing about not pushing right up against the target is it allows for uncertainty. If there's uncertainty in the numbers, that's fine. It's not so fine if you're pushed right up against the limit. But we're not. We're not even close to the limit. As you'll see, we're even further away from the limit than that.
Okay. Thank you. I'm Peter Weiskel from the USGS, and I'm just going to share with you some of the information that we know about work that was done back in the 90s, primarily by the USGS in developing an understanding of the original plume, how it developed, and where we were able to monitor it, and for the period we were able to monitor it. And basically, here's the plant, and over time, slowly, a zone of solute-enriched groundwater, which is what a plume is, including various kinds of dissolved nitrogen, grew at the site. And for the most part, as you can see, it did not go straight toward the marsh. It went off at an angle. And that's because the plume was down at a depth in the vertical where the driving force for groundwater flow was slightly at an angle from the water table gradient. The hydraulic gradient at depth was more to the north-northwest rather than the straight northwest. And we go to the next one? Okay. The last and the most recent sampling areas were right here along the bike trail, in addition to some screening level analyses we did with well points in the marsh itself. We've also, in the course of drilling the wells here along the bike trail, we're able to log the stratigraphy. That's to say the sediments in the borehole that we made prior to placing the monitoring well in the 2-inch monitoring well in the borehole. And what this shows, and I'll show you a cross section in a second, is that the plume has, as I said before, the deep part of the plume that is moving more to the north-northwest is below a confining unit, a fine-grained unit that we saw in the logs of the borings. And then there's also a section that's above that unit, and in fact was sliced off by it, and that was still quite a bit below the marsh, the base of the marsh, but nevertheless above this unit. In the next slide, we'll show you schematically what it looks like, and then I'll show you one with the actual vertical depths shown. And schematically, the main body of the plume is below this clay unit, and it's important to point out that this is not part of the marsh system at all. This is considerably deeper than the marsh sediments, and is really a glacial deposit, glacial lacustrine. That's to say, when the ice sheet, the lobe of ice that sat in Cape Cod Bay was retreating, it was impounding a lake, and the feather edge, or the inland edge of that deposit is what most likely we're looking at here along the bike trail. It gets thicker as you move out toward the bay and offshore. It acts as a confining unit. That's to say that the flow system is different in direction. The hydraulic heads, that's to say how high the water level gets in a well that is screened in this area as opposed to up here. It differs from the height of the water table. Again, as you move down the bike trail, you'll see, or we see in the data, the fact that there's a little smaller plumelet, if you will, located above this unit. If you go to the next slide, this is the actual, these are the boring datas and the geophysical logs that show, first of all, that clay unit, which basically parallels the original surface of the ground. As you all, if you've been on this part of the bike trail, you'll know that it's been cut into the original surface, which actually goes up like this, and then down like this. So it's pretty much parallel to the original ground surface. And again, the main part of the plume is here at considerable depth, about 50 feet below sea level. The top of it being at about minus 40 feet, let's say 40 feet below sea level to roughly 60 or 70 feet below sea level. And then in this vicinity, we see that some nitrogen-enriched groundwater above the clay unit. We can distinguish its location from multi-level or vertical water quality sampling done in this area right here. So this is the plan view. This is the cross-sectional view where you are looking at a slice through these two portions of the plume. Yeah, at this point it's important to stress that the bulk of the mass, if you will, or of the volume of plume water is located below this unit, or was in 1999. And a smaller fraction of it is down here, still considerably below the marsh itself, at a depth of around 25 to 30 feet below sea level. And let's go to the next one. Okay, so that is the story as best we know it from our last mapping of the plume extent, and particularly what's going on around here. Since that time, both before and after that time, I should say, we also did detailed monitoring in the creek system. What Brian mentioned earlier was this site right here, which is this most inland or most upstream sampling site for the total maximum daily load study, or the MEP study, and there was other ones further downstream in the system. Well, the fact is, as you move further up the system, it becomes more and more groundwater dominated, and if in fact any plume is discharging, or any portion of the plume is discharging, you have a much greater chance of picking it up, of detecting it as you move upstream. And as Brian was indicating earlier, the salinities get lower at low tide as you move upstream, and the background nitrogen concentrations tend to get higher. But what we did at these three sites, and they were chosen quite deliberately, was evaluate, first of all, right in the groundwater seepage zone, and I'll show you in the next slide what we mean by that, the boundary seepage zone around the edge of the marsh. We looked at concentrations. We looked here at Site B at what is draining Hurley's Bog, which Hurley's Bog extends down in this direction, and looked for potential impacts on the water quality from Hurley's Bog. And then at Site A is basically an integrator site of all of this area. And just for the sake of brevity, I've shown here the summary of most of our data from the more recent sampling, stacked up here in milligrams per liter. This represents seasonal variation. In this case, June to February. Not shown here is more recent data that goes through the summer of 2011. And they're stacked up next to the baseline data that was just after in the few years after the Tri-Town plant started operating, and when the plume was still very much on the plant property. So as you can see, the creek concentrations are well within the baseline range of concentrations and aren't, if one was looking at the plume itself, for example, what we saw, say, 2 slides back in this vicinity up on the bike trail, it would be about 20 times higher. It would be up here around 15 or so milligrams per liter. And as you can see, it's down in this range that we would expect to see under background conditions in the creek. So as is pointed out here, the sites do not correspond to the MEP sampling sites. And site A is about 800 feet upstream, and the concentration at this site is about 0.8 milligrams per liter. Yeah, another point to make is that that's total nitrogen. We're looking strictly at nitrate nitrogen here. So go to the next slide. Okay, this you can speak to this. There's other hydrogeologic work done by others. Here you go.
Okay, actually, I drew the short straw on this one. This is modeling done by Ray Pierce and Jesse Schwabbaum, specifically was the modeler who did the groundwater modeling. It's a particle track model. And the basic point, it's very confusing to look at, but if you listen to my words, maybe it'll help. The 500,000 gallons a day, the 504,000 gallons a day, which is 0.5 MGD, is the sort of the planned discharge, average discharge. The 740 is the maximum capacity of the plant, because sometimes you're going to have a high flow and you're going to discharge a little bit more. So they chose, we did not do this, they chose to model then the average and the max. And what you do is you see the model with red dots, basically with particles, and you look to see where they go. What they come up with is that on the average, it's this line here, that about 2/3 of the particles end up in Namskaket Marsh. They have 8% ending up in Little Namskaket Marsh, and they have about 1/4 ending up in Cape Cod Bay directly. Now, some of this is debatable, but the basic point is not, in that they have less than 100% ending up in Namskaket Marsh. And I want to bring you back again to the simple things in life. The MEP looked at this as, what if all the load from the treatment plant goes into the marsh? Do you go over the limit? No. If you look at Peter's data that he showed on the clay layer, he has 90% of the at least existing load is under the clay layer and will not make it to Namskaket. And so we're looking most likely that a large percentage of the future, any future potential plume would also be under the clay layer and would also not make it to marsh. So the number's down. If you use his number now, it's only 10% would make it to the marsh. If the new discharge breaks that a little bit, then it may be 50% or 40%, but it's not 100%. And then you look at this modeling here, and you're getting about 2/3 of the potential load from the future making it to the marsh, or 1/3 not making it to the marsh. So we're sort of constraining that. We don't know exactly how much is going to make it to the marsh. I'll tell you right now, if anybody tells you they do, then take that bet, and I'll take half of your side. We don't know, but what we do know is, if all goes to the marsh, the nitrogen is going to be a problem. If the clay layer holds up, then virtually none of it's going to go to the marsh, so it's not a problem anyway. And if this modeling's correct, then on the order of 2/3 it'll go to the marsh. Okay? But still not enough nitrogen to make anything happen. All right. Some work from USGS, haha.
Yep. Do you want to speak to this?
This is what Peter was talking about. When groundwater enters the salt marsh, this is actually, what I should tell you, is one of the best hydrologically studied salt marshes in the United States is Little Namskaket Marsh, believe it or not. Or is Namskaket Marsh, and the upper pocket. And this was actually a paper that was published years ago that tracked where fresh water enters into this marsh and why. And what it found was that at the very edge of the marsh, and you can go out and see it yourself, you'll see groundwater seeping up at the edge. In the middle of the marsh, because you have meters of very hydraulically restricted peat, in other words, water doesn't flow through peat very well. what you have is not much flowing up until you get to the creek bottom, and then you get about 2/3 of the freshwater in this marsh coming through the creek bottom. And this is very similar to what Redfield found decades before in the Great Marshes in Barnstable, and what we found in other marshes on the Cape as well since then, originally described though by Redfield. So what it means here then is, now we start getting into another one. Let's say all of the load from the plume goes to the marsh. How much of it actually interacts with the marsh? Well, it's not interacting with the marsh because it can't get up to reach the plants through a couple meters of very low conductivity peat. It can interact with the marsh at the edge, about 1/3 of it. And it can interact with the marsh through the bottom, but it ends up that this water is flowing out at low tide so fast, there's nothing going on there. The nitrogen concentrations at the bottom of the creek are already very high because it's already fresh water. And you say, well, what about at high tide when it gets diluted going in? Well, that's fine, except that there's many hundreds of fold more salt water coming in on that tide to flood the marsh than there is a little bit of water that seeps in during that period. So again, this then is your critical number. What we're trying to do is restrict what we don't know down into the numbers that we do know, and then is it big? Okay, so if 100% goes to the marsh, only 1/3 of that will have any value to the marsh. If only 10% goes to the marsh, then only 3% would affect it. And if the Schwab thing is correct, then 1/3 of 2/3, and somebody can do that math for me, but it's less than half. So it ends up being the numbers as you start putting together all of the information from Namskaket, you start constraining things down that actually the nitrogen from this plant, if it gets built, is not the big deal. I'd like to read you something, if I could, just for a second. I wasn't going to do it, but...
Can we go back to that
Go ahead.
slide? Just, let's see if you have the...
My colleague has to do that.
Do you have the pointer here?
It's my pointer.
Yeah, I just wanted to stress that this is not percentages of the plume as we didn't observe this. In other words, that at the bike trail, the plume is at considerable depth. You know, even that shallow part that comes under the marsh and is overriding the glacier clay unit is considerably below the groundwater that's coming out of the edge. You know what I mean? This is shallow groundwater. The plant itself is up. It's the groundwater system in this part of the Cape. If you go 800 feet back away, you know, toward Route 6, you're almost at the groundwater divide. You know what I mean? So the groundwater is going, and the plume itself is really going deeper based on our work at the bike trail. So this isn't. Brian truly was giving you a worst case scenario.
Yeah, and in his world, worst case is 3%. So, I'd like to read you something that John Teal wrote on a study for the town in 1983. And his basic contention was that the potential impacts to the marsh of putting in then Tri-Town, but it's as true today, the potential impacts that you have to worry about are the effects of fresh water, the effects of nutrient loading, and the effects of any toxins if they're there, but of course, that's not really the case here. But so it's really the first two. Those words are as true now as they ever were, and they're true for every system. And we've worked on systems all around the world, and it's true. That in this particular case, though, it's not the nutrients, but then there's the fresh water. And that's then the next thing that we have to look at, which John didn't have the access to at the time, but we, of course, now in the intervening 30 years, we now have access to that data. This is that pocket marsh in upper Namskaket, and what you can see here is the Phragmites all around the edge, some Phragmites in spots in the center, and then you see these lower areas which we have a map which I'll show you. That was again something to do with USGS, with Peter specifically, but it's like some high marsh here, and then there's some low marsh along the edges. But what strikes you always when you look at these systems is the Phragmites, because that's what you see. Now there's two reasons for Phragmites to be in this system. Well, yeah, basically two. One is, it's an opportunistic species that comes in when there's disturbance. And all salt marshes are like the dumping grounds for the ocean. When you go into salt marshes, as you go up to the headmost parts, where you find is boards and cans and bottles, everything else gets swept in there. Also, stems and dead frag and dead tall spurgeon all gets loaded up there, and a lot of times it ends up at the head of the marsh and it kills the plants. happens in Sipwasset Marsh, which doesn't have this problem. It happens in this marsh, it happens in great marshes. So what happens? And so when that happens, then you get these invasive or these opportunistic frag. We don't know whether this is the invasive species or whether it's just an opportunist. But in any case, this is what happens when you kill the plants. Now remember, all this is before there was any wastewater treatment plant. All right, that's just what happens. And so we have all of this frag. Next. And this is a nice piece that was done. And what you see here is that this this green here, this long patch all the way along the edge, is that frag. And you see some in patches along this edge here, and then you also can tuck in some other species which are more brackish or more saline salt marsh, typical salt marsh species like Peyton's, salt marsh hay, salt marsh cordgrass, spikegrass, things like that. But when you look at this too, you see this just mosaic of plant communities. And the reason for that is the disturbance creates that. By continually disturbing and disturbing, you get this patchwork. This is a natural part of this marsh and every other marsh. If you look out at the lower portions of Namskaket, you're going to see one species or two species as far as you can see. And it's because it doesn't have the same physical disturbance. It's a physical disturbance. And the plants that come in are salinity related. So in further away from that edge border where Peter was talking about, where the groundwater seeps in at the edge, once you get away from that, then you start getting the more salt marsh species. Along that edge, you get Phragmites. And this is my pat Peter on the back after 25 years of getting his PhD, that he drove all these well points. It's 114 sites. And he sampled the salinity up and down those with depth in these things, and he measured the salinity. And what you find then is you can contour it, and what you see is along the edge you're getting between 4 and 0. That's what that contour means. If you're on this blue line, it's 4, but if you're landward of it, it's going down to fresh water. And same thing down here, it's 4, here's 8. And the high parts are away from the upland, away from those areas where it seeps in. And they're also supporting, the salinities here and the plants here are supporting that original model that I showed where not really any fresh water comes up through the peat. Because if it did, it would all be frag. Okay? So what do we know now about the plants in the system? Well, we know fresh water is probably a problem and nitrogen's not. And we know that if you put more fresh water into a system like this significant, it's very likely that you're going to get some more Phragmites, some other freshwater plants. But you can only get it up to the creeks, because these creeks are what is protecting some of this. You can't, you notice that most of the high salinity is on the other side of this deep creek here, especially if it's deeper and deeper, and it's not getting up onto the marsh surface. So when you look at the marsh plants, they're seeing a different salinity than what you see in the creek at low tide. That's very typical. So that's what we know about the fresh water. Obviously, if the plume goes under the clay, it's fairly certain that you're not going to get much freshwater input. But what I would just say is that going all the way back to teal 30 years ago, is that, yeah, it's possible that you're going to get some more frag. However, this marsh used to be all freshwater marsh at one point. Now, it's before any of us were alive. But salt marshes on the Cape are built on top of freshwater marshes, and they were overtopped with rising sea level to be salt marshes. And then in the upper reaches, they're still freshwater marshes or brackish water marshes. If one believes that sea level is going to accelerate with climate change, regardless of who's causing climate change, just if the climate is changing, or more simply, even if just sea level is increasing, and even if it doesn't increase, it is rising. It's been rising for 18,000 years on the Cape. It's unlikely it's going to stop today. So very likely that the system will come into a new balance again, and it's going to look pretty much like it does today, but with some more frag in it. Of course, you could always prevent the frag from coming in by going out and picking up all the trash too. Okay, so what do we know? Right now, Namskaket Marsh is currently not impaired by nitrogen. We know that. That's an MEP finding. There's no evidence of it. The second thing we know is that the proposed treatment plant and build out of the watershed will not exceed the capacity for nitrogen. assimilation by this system. And in fact, remember that the build-out, what you guys control in terms of build-out of commercial mainly, will exceed any potential load from the treatment plant. So the third thing is that the plume, with the proposed wastewater treatment plume at a 500,000 gallon a day average discharge, only sort of 0% or more recently 10% say, up to 2/3, depending on if you want to look at the geology or at the Jesse's modeling, that only between 0% and 2/3 of the plume will actually, or potentially even reach the marsh. And remember, only 1/3 of that, whatever can reach the marsh, could even potentially reach the plants. And finally, the fresh water from the proposed treatment plant on the upper pocket marsh is currently brackish and supports large areas of frag in pockets. And additional fresh water may lead to an expansion of that brackish frag, mainly along the borders of the existing pockets, but it's going to be confined by the very deep creeks, because since it's coming at the edge of the marsh, once you get in a little bit, it's just not coming in anymore. But it will flow across the marsh a bit as the seepage goes up, and that's why you'll get the change. What are the fresh water coming in through the bottom? Is it going to change the marsh ecology? Mainly because at low tide it's already fresh water. So it might be a little deeper, but it's actually much deeper. Instead of an inch, it might be 1.25 inches. But it's not going to be like 10 feet of fresh water. Not going to be able to detect that change. That's it for this section. And then I think we go to either Amy or Tara.
I think we just got a very quick update from Amy and another quick update from Tara on the monitoring that both organizations have been doing. Amy?
So we at the Center for Coastal Studies have continued to monitor just the surface water quality. We picked up pretty much where MEP cut back. So in 2006, the Provincetown Center for Coastal Studies started a long-term water quality monitoring program that includes monitoring of about 70 stations located all over Cape Cod, from Provincetown up to Duxbury. 3 of these stations are located in Namskaket Marsh, and we continue to this day to monitor these 3 stations for the basic water quality parameters that have been discussed: temperature, salinity, dissolved oxygen, turbidity, chlorophyll, nitrogen, and phosphorus. In 2012, this past year, we were lucky enough to get funding to monitor for pharmaceuticals. We monitor for pharmaceutical contaminants in Namskaket Marsh, as well as 4 other embayments on Cape Cod. Levels were detected in Namskaket, but they were lower than the other 4 marshes that we looked at. We have also worked with APCC. We continue to expand what we're doing in Namskaket Marsh because it does seem to be such an important area. We work with APCC on looking also at dissolved organic nitrogen and phosphorus in the pore water. So we're looking at surface water, basic water quality parameters. We're looking at pore water, and we're also hoping to include more of the pharmaceutical contaminants in our work. And I'm not going to get into the data, but I'd be happy to answer any questions that you have about it.
Okay, thanks, Amy. And we do want to keep moving along because we do want to get to Q&A, so thank you. And Tara, you want to just do a
Yeah, but I was going to use the slides.
update?
Can I borrow the laser pointer? And I'm just standing up because I can't sit there and point.
Okay.
But slides.
If you just move.
Do you mind if I stand here?
Oh, sure.
Because I don't know that my voice will project otherwise. Let's see, where is this? Okay, so Tara and I work for the Association to Preserve Cape Cod. I'm going to talk about the salt marsh monitoring program very quickly. Next slide, please. The objectives of the program are to obtain scientific information on salt marsh health, increase awareness of salt marshes, stewardship for, and document the need for and effectiveness of restoration. Next slide. Tidal restriction. I thought I didn't have much time, so About 200 salt marshes on Cape Cod are tidally restricted. We are monitoring 18 of them. Next slide, please. Namskaket Marsh being one of them. This is you've seen enough aerials of Namskaket tonight to maybe get the orientation here. This is a Cape Cod rail trail. This heads out to Cape Cod Bay, and this is upstream of the culvert. Primarily, my goal is to look at tidally restricted and restored salt marshes. The culvert underneath this rail trail was replaced in 2007. We were monitoring for salinity, plants, and birds. In 2006, we have 1 year of pre-restoration data, and then we have several years post-culvert replacement. So we monitor salinity in plants along these transects here. Next slide. Currently there are flashboards across the culvert. This is done typically in any kind of culvert restoration project. However, the flashboards are still in place. This picture was taken last summer, 2012. The construction was done in 2007. Next slide. So our plant monitoring is done along transects that run from the creek edge to upland. We use a 1 meter square quadrat, and we identify all the plants and quantify all the plants within that quadrat. Next slide. This is a quick, this is obviously way too much information for tonight, but basically this pretty much mirrors a lot of what was said about the plants that are in the salt marsh. On the reference side of the salt marsh, the side that is closest to Cape Cod Bay and not tidally restricted, you'll see typical salt marsh type plants, what we call halophytes. On the study side, which is, I guess you were referring to as a radio tower marsh, that has predominantly frag and other plants that do not tolerate salt. Next slide. We call those the plants that are salt tolerant are called halophytes. 97% of the plants on the reference side are salt tolerant. Only 14% of the plants on the study side, the side that is upstream of the culvert, are halophytes. Prior to tidal restoration, prior to the culvert being replaced. After the culvert was replaced, 27%. So there was an increase in halophytes, but not nearly what you see on the reference side. Next slide. So basically what it tells us that the restoration of the site is not complete. Next slide. So we also monitor for salinity. We take surface water salinity and pore water salinity. Next slide. And over here you have salinity on this axis and our sites on this axis. If you're looking at the study side, the whitish bar is representing the salinity at the salt marsh prior to tidal restoration, which was about 2, very much like what Brian was saying. Again, these are all taken at low tide. I don't do any of the monitoring outside of that time frame. The green bar is after culvert restoration, and it's up at 10. So there is an increase post-culvert removal. However, if you look at the reference side, there's also an increase from one year to the next. And so we're looking at probably some environmental factors, weather, wind, rain events, or no rain event. Next slide, please. So basically, we're looking at a slight increase in salinity, but still, there's no additional increase after that first year. Next slide, please. So basically, in summary, our culvert replacement has narrowed the difference between the study and the reference side. However, it is not as effective or as extensive as it could be. Next slide. It's also important to keep in mind that there are numerous threats to a salt marsh, and if we just look at one, then we're going to be not looking at the whole system, and we're not going to be fairly adequately protecting and preserving and restoring our salt marshes. And next slide just gives my contact information if anyone wants to get in touch with me.
Thanks, Tara. Appreciate you moving along quickly. There may be some questions when we get back to you. And I'd like to just turn to Brian Dudley from DEP to kind of summarize this first part of the panel discussion. Do you have slides, Brian?
No.
No. Okay, we get the lights back up then, please.
I'll be quick. I think what's important to take away is that everything that has been said here tonight is consistent with all the information that has been provided throughout the entire study process, from the initial evaluations through the MEP of Namskaket, through the development of the comprehensive wastewater management plan, up until today. And that the assumptions that have gone into the development of any of these plans have been conservative. Brian explained what the conservative elements were in the modeling. Peter has shown what the conservative elements are in his evaluation of the plume. And the work that Wright Pierce did through their groundwater modeling also showed conservative assumptions. And I think an important thing, though, also is to distinguish, when we talk about impact on the marsh and where the plume is potentially would come up, and also given what the existing plume is, what we know about, is, generically we talk about the marsh, but the particle tracking that was done shows that the predominant expression of the plume, once it leaves the groundwater and enters the surface water, is in the creek itself. It's not the specter of effluent bubbling up on the surface of the marsh. Peter had demonstrated how it runs deep, where it comes out, and that was confirmed with Jesse Schwalbaum's model that he had done with Wright Pierce. And the other important factor is in that modeling, he didn't just take the regional model. He took a more localized approach and brought in more site-specific data to refine the model and provide a finer-grained analysis. And again, his conclusions were consistent with what has been demonstrated before. So I think it's important to understand that the message has been consistent. The conclusions have been validated and verified from a variety of sources, and that if the department was not satisfied and confident that the results of these analyses indicated that there was no adverse effect or impact on the environment or on the system itself, we would not have approved the plan as it came through. And that's not to say that there are other options, but at least the message is consistent, the conclusions are consistent, and the conclusions are verified from different sources. Thank you.
Thank you, Brian. And thank you, panel. Let's round of applause. Direct your questions through me. I'm going to try to allow 2 to 4 minutes per question, including the time to ask the question. Then we can move along quickly and use up as much time as we can to get through all of this. So now we'll go to part 2 of the evening, and please, again, when you raise your hand, identify yourself by name and the town you're from, and if you're willing to if you're affiliated with somebody and want to mention that, that's fine too. We have microphones circulating, or will have microphones circulating through the audience, so do I see a hand? Right down front, yes sir. And there's a mic coming, right down front, second row here with a mic, please.
Paul Cass, All Lanes. That'll be a million questions. Phragmites. I heard, people stating that there's little or no damage from the nitrogen and the oxygen, et cetera, But the Phragmites are what concerns me. And as they start, the fresh water helps them, and they grow. They start to take over. They're 20, 30 feet high sometimes. They take away the oxygen, and then they catch litter. And now years may go by, but they soon take over the whole area. The level rises because they're catching everything, and then they restrict the flow of the water. So what you end up doing is more and more fresh water starts taking over, and this in turn, they start growing. And the invasive species from Europe are pretty much, they're more salt tolerant. So if they get in there, you have a never-ending thing of Phragmites taking over the salt water.
So the question is, you want a little bit more information about the Phragmites? Is that your question?
Yes.
I think Tyler might want to start with that. Well, I think there's a question there someplace. There's a statement with a question embedded in
the future of the Phragmites, if they keep on growing, you can't cut them, you can't burn them. The only way to get rid of them
is to increase salinity, is to increase salt water.
And they themselves increase the fresh water.
Okay, let us talk a little bit about, maybe Tyler, just put Phragmites in a context about this marsh versus other marsh. Invasive species, timetable, and so forth.
How much time do I have?
This is where you catch up.
Okay, so Phragmites is present in Namskaket. It's present in most marshes across the Cape. It cannot tolerate salinity higher than 22 parts per thousand. 18, there's a range, there's a bit of a range there. But, and yes, often Phragmites comes into a system that is fresh, has freshwater input and or into disturbed areas. The only way to combat it, besides cutting it, there have been other methods tried, but in a salt marsh, basically what you want is to increase your salinity. In some of the marshes, I mean the marshes, the pocket marsh that was shown on the maps that Brian and Ed and Peter were referring to, isn't a marsh part of the marsh system that I work in. Mostly I work in the marsh that is prior to the culvert and then upstream of the culvert. By opening up the culvert and then removing the flashboards, we're going to bring in more salt water and take care of a good chunk of that Phragmites that is viewable from the rail trail. I'm not sure that I'm answering your question.
Good. All right, I think that's very good. Any other panelists want to add just 2 minutes about Phragmites? Brian?
Yeah, we do a lot of work on Phragmites, and we've worked on the 25,000 acre Phragmites restoration project in New Jersey as well as here. And from that basis, what I can say is there are two species. There's the normal natural population, which has a much lower salinity tolerance, and so you get rid of them with much lower salinity. But the one that Terry's talking about, at 22 parts per thousand, is an invasive species. And it is expanding without any changes in anything else. It's just because of higher tolerance and it outcompetes the other species in the marsh. Fine. That's happening all over the place. The reality of the world, though, is that the sediments that you're talking about are already anaerobic. Salt marsh sediments are anaerobic. There's no oxygen in them. The plants are adapted to live in those soils. So to say that, well, you get all these plants in there and then all that organic matter makes it anaerobic, it was anaerobic before that. It's anaerobic now. It'll be anaerobic tomorrow. In terms of the freshwater issue, I can understand your point about trapping things and holding water in, but that's not going to happen in the pocket marsh because it has a myriad of creeks penetrating it. They're very deep and they're not going to start impounding fresh water. In fact, many freshwater Phragmites marshes tend to sink, not rise. So it depends on the situation. If it's a riverine system, not a river here, but if it was a river, that might rise. If there's other things that could happen. But in this particular system, what you're really just dealing with is freshwater versus frag, and it can only expand into those areas where the freshwater is going to change significantly, and those areas are limited in the marsh.
Okay, thank you very much. Another question? Yes, I see a hand back here in the middle of the auditorium.
Since the restoration of the culverts...
could you just identify yourself?
My name is Robert Cunningham. I'm a resident of East Orleans.
Okay, thank you.
Since the Namskaket culvert was dramatically expanded in 2007, and now I understand we're getting close to removing the flashboards. If the flashboards are removed, will that increase the saltwater flow on both sides? And there'd be more capacity for Hurley's Bog to receive salt water, so that would, one would think, increase the tidal levels on both sides of the culvert.
Okay, thank you. Tara, would you have to...
I don't know if you saw the maps, but Hurley's Bog is not, it's not going to impact Hurley's Bog. If you remove the flashboards from the culvert, it will inundate what I refer to as a study marsh. They refer to as the radio station marsh. I think that can get brighter, but I'm not sure. I'm almost blind. Thank you. The Hurley's Bog area is separated from the marsh will be impacted by the removal of the flashboards.
Okay, thank you. Over here in the yellow sweater, please.
Hi, John Sargent, live on Crystal Lake Drive. One of the things that I've been reading in the paper recently with some of the people who are objecting to this plant is pointing to what happened in Hull, where I forget, 10 million gallons of untreated came into the I forget the exact numbers, you would know them. What is the context in relation to the size of our project? We're talking, I think we're talking 4,500 or 5,000 cubic meters a day. How does that compare to the 10 million? And
Brian, do you want to take a shot at that?
I mean, how much is that compared to the 10 million? Is this a,
What you're talking about here is 500,000 gallons per day.
okay,
So it's much less.
20 days worth,
Yeah.
okay. Thank you.
I'm sorry, did you get, did you get answered properly?
Yeah, I was just wondering what the proportions were.
Okay.
Whether this was, whether we were having 20 million gallons a day or whether,
Oh, yeah. And the answer is 500,000. Brian, want to answer that?
I think it's also important to remember that what happened in Hull was a catastrophic event, and that the location of the plant is entirely different than what you see here with the existing plant at Tri-Town, or what may possibly be built in Tri-Town. So it's not really an apples to apples comparison, but it was a catastrophic event.
the reason for my asking was that it sounded like they were trying to compare the two as equal events. And I just wanted to make sure that the proportions were clear, and the 10 million gallons weren't going to come in, or maybe they would, I don't know, in a day or whatever.
But it's very different. Take what Brian said. It's not, you can't just do a proportionality. It's the Tri-Town is way up on the hill, and it's a groundwater discharge, and it's just not going to have, you're not going to dump 500,000 gallons a day of wastewater into the marsh, in this case, because of what he said.
Even with a catastrophe.
Right.
Could I,
Okay, I didn't see a hand, but I see someone with a microphone. Yes?
Could I further answer that question? I believe that there is a difference between the Hull situation. They were dealing with a sewer system where some of the sewers were from the 19th century. And their sewer and stormwater systems were combined. And there was an overwhelming, after a lot of storms and melting snow, overwhelming of their system. We will not have that situation.
Okay, I think good. We've dealt with that question. I'd like to go on to another topic or another question. Right here in the...
Yes, Neville Trevisit in Orleans. In the final CWMP, it was dated December of 2010. Appendix F, page 31 of 60, it states, quote, "Of most significance is our finding that the effluent impacted groundwater will emerge in the Namskaket and Little Namskaket marsh systems." And in a January 28, 2011 letter to the town of Orleans on page 9 from the Massachusetts Executive Secretary of Energy and Environmental Affairs, he states, quote, "As described in the SEIR, Single Environmental Impact Report, approximately 67% of treated water effluent from the Tri-Town site will discharge to Namskaket Marsh, 9% discharge to Little Namskaket Marsh, and approximately 25% will discharge into Cape Cod Bay." That totals 101%, but must have been rounded. Now, members of the Water and Sewer Commission and Orleans CAN organizations have disputed these statements, because I wrote these in a letter to the editor, and they said that all of the effluent discharge will go into Cape Cod Bay. And I think Dr. House stated, we don't know where they go. We can't be sure where they will go. My question to the panel is this: do you disagree with the statements of the CWMP and the Executive Secretary of Energy and Environmental Affairs? And if you disagree, hasn't the town of Orleans provided false information to the Commonwealth and to the Cape Cod Commission?
And normally when I get the political statement at the end, I sort of refuse to answer the technical side, but this time I'm going to answer the technical side.
Okay.
Just because you don't know exactly, that wasn't the question?
No, let's hold on now. Wait a minute. You're asking for the panel to try to reconcile some of the different numbers that you cited.
The question is, do you disagree with the CWMP and the Executive Secretary of Environmental Affairs? And if you do disagree, hasn't the town of Orleans provided incorrect and false information?
Okay. The questionnaire has cited a couple of different numbers from Executive Office of Environmental Affairs, and CWMP, and his interpretation is it may be a little different from some of the numbers he's seen up here, so he's asking whether the panelists disagree with the numbers cited there. Brian, do you want to try to put it into context?
Yeah, I mean, the first thing is because we don't know exactly where it's going doesn't mean it's going anywhere. It's either going to Little Namskaket, or Cape Cod Bay. If you look at the USGS data, it'll tell you that mainly it's not going to Namskaket. Okay, and if it's not going to Namskaket, it's likely not going to Little Namskaket either. But we don't know for sure. If you look at the modeling that Brightcrest put in the CWMP, which I presented tonight, it has those same numbers in it. Basically 67%, 68%. And that's based on their modeling, and that's fine. I don't know exactly how they parameterize the clay layer going out or away. Peter, you might be able to add on that. But so that's one thing. But the critical piece here is not whether that model was correct or incorrect. The critical piece here is if it all goes to the marsh, is it have an effect? And the other piece is that if that modeling's correct, does that have an effect? And the other thing is if the USGS is right with what they have now, it's not really right or wrong because we all sort of agree that there's three possibilities, does that have an effect? And the answer to all those questions is, for the nitrogen, no. And so, was it incorrect what was presented to the Secretary? Well, you know, probably not, because they cited their source as the modeling, and that's what the model showed. They could have said, well, it could be less than that, could be zero. But then, you know, why? You know, they don't have to do that. That's less, it's not more. They could have said, well, it could have been 33% more. They could have said that, but we have no evidence it's more. We just took that as the most extreme thing that we could pick that everybody could agree on, that if it all goes there, then it's not a problem. Or if it all went there and it was a problem, then we have to get out the very sharp knife and start teasing it back and say, well, where does it become a problem? Okay? So I don't want to do it. I get involved in these discussions all the time, but the reality is that the real mission is, what's the town going to do? If they do a discharge at Namskaket, is it going to have an effect on the marsh? And I'm a scientist and I like marshes, and so I'm telling you that for the nitrogen, no, for the freshwater, a little bit.
Okay, thank you. Any panelists want to add to that? Okay. Brian?
The only thing that I would add to that is that we did review the CWMP. The modeling was in accordance with accepted modeling principles. There were certain conclusions that came in, and the proportion of wastewater reaching even the Namskaket system, or the Little Namskaket system, or Cape Cod Bay, was dependent on the flow that was being generated. And that table, as Brian said, had been presented tonight. We don't have any reason to dispute the conclusions of the CWMP, and we really have no opinion on the issue about what may or may not have been stated in the paper, because we haven't seen it and we really can't evaluate it just based on something that's presented here tonight.
Okay, so I'm going to have to move on to the next question. And would you wait for the microphone so we can get your name and everyone can hear the answer? You get the microphone right there? Okay.
Hi, my name is Vicki Reyes. I'm familiar with some of the panelists. I've seen them over the years. Dr. House and Dr. Peter Weskel have written numerous studies on Namskaket Marsh over the years, because it was actually the first marsh that a septic treatment plant had been discharged into, and they've made their quite careers out of papers and studies that they have quoted on Namskaket Marsh. It's come to my attention that there was a study done by Linda Deegan from Woods Hole Marine Biological Lab and sponsored by the National Science Foundation on coastal salt marshes, and one of the things I saw from the Science Foundation was why are coastal marshes falling apart. They did a further environmental risk was identified by these people in the fall of 2012, when for many years everybody thought there was, our salt marshes had an infinite capacity to assimilate nitrogen without damage, because there had never been a septic treatment plant discharging into a marsh before, so really there was nothing to base the foundation on other than their theories and their studies, which lasted only as long as the funding did. and then the marsh really stopped being studied. In a study of Plum Island, the salt marsh, Ms. Deegan and her colleagues found that excess nitrogen stimulates plant foliage growth at the expense of root development.
Are you going to get to a question on this one?
Yeah, and ultimately destroys the underlying salt marsh structure. And their study demonstrated that nutrient enrichment, a global problem for coastal ecosystems, can be a driver of salt marsh loss. And we know that nutrient levels commonly associated with coastal eutrophication increased above ground leaf biomass, decreased the dense below ground biomass of bank stabilizing roots, and increased microbial decomposition.
How much longer is the statement going to be before we get to the question, please?
Doesn't this work by Ms. Deegan raise questions about the risk to Namskaket Marsh over time, and the fact that there is definitely, couldn't there be the possibility that excessive nitrogen, because this is an original environment where this situation exists, actually is going to suffer because of the excessive nitrogen being loaded into the marsh as well as fresh water?
Okay, thank you. Brian?
We've been studying Great Sequoia Marsh since 1970. We've been adding fertilizer to it since 1970 at different levels. It's the world's longest nitrogen marine experiment, and it's a long-term eutrophication experiment. So that's part of what we base it on. It's not a one-year study. The other thing is with the Deegan study, it's interesting. It's a sort of a one-off study. It's interesting, but it's not definitive. And the reason is that they put nitrate, which is the oxidized form of nitrogen Peter was talking about, into the creek water to raise the entire concentration of the creek water in just nitrate alone to higher than what we see coming in the freshwater seepage into salt marshes. So it's a huge amount of nitrate, and nitrate's an oxidant. It oxidizes pyrite, it oxidizes a whole variety of things. It does a lot of things. So it's not that under that application that it wasn't a problem, it's just that application was orders of magnitude higher. It's sort of like, we're going to see if you get cancer, we're going to make you drink 1,000 gallons of milk a day and say that milk's bad. It's just, but it's an interesting paper. It's very interesting. It's in the face of all of the other nitrogen papers that use much more realistic nitrogen levels. Now, the other piece of that is, if this plant never gets built here, the load to that marsh is going up. And in fact, if you look all around the Cape, which we have done, and in southeastern Massachusetts, and looked at the nitrate and nitrogen going into those marshes, we find that they're very high. In the marshes, you wouldn't know they were impaired or aren't impaired. They aren't impaired, for the most part. So it's a natural thing going on. You have an experiment, and when that paper came out, I got 20 copies in the first day that it would hit the thing, and the bottom line was, oh my God, look at this, what does this mean? And my comment to myself was, well, here we go, this will be the next year and a half of my life, I better read this paper really carefully, trying to explain to people that when you do an experiment and you jack the levels way out of proportion to anything found in nature, that you're apt to get something different than what's found in nature. But it's worth looking at, and I just want to tell you that our level of adaptive management is, even if I'm 99.99999% sure, we're still going to look and follow it up. And we're going to adapt if there's any negative effects.
Great. Thank you, Brian. All right, a question back here, please.
Hi, I'm Rick Siegel. Thank you so much for answering so many of the questions that I had, and I'm pleased to know that Namskaket Marsh is going to be in good shape based on the increased flows. But I need some clarification, I think. There was something that was mentioned twice, and it was quickly mentioned once, and then I heard it again, just twice. That the threat isn't so much the maximum load of the plant being proposed, but the threat could possibly be from the commercial build-out, and that was mentioned twice again tonight, and I just needed some clarification of that. Is that something that we should be looking at? I need to know more about, and that's my question.
Ed, do you want to take a shot then?
If you look in the MEP report for Namskaket, you will see an existing conditions nitrogen load, and you will see a build-out nitrogen load. The build-out nitrogen load is based on existing zoning in the town, or actually the towns, since it's both Orleans and Brewster. And so within that watershed, actually to the radio tower marsh, There is a large portion of commercial and industrial development that is possible under zoning. And that is what drives the build-out load. If you look in the report, you'll see that it actually, I think it increases 5 times within that watershed. That is in large part that commercial and industrial development that is allowed under zoning. So build-out is, when we do the MEP reports, is a reflection of whatever zoning allows at that time. Now, zoning may have changed in that watershed, and that would reduce things. Zoning, you may want to change zoning within that watershed to reduce what that would be, and that would reduce your nitrogen load.
Okay, thank you, Ed. Question back here in the ridge.
My name is Jeff Eagles from Orleans. There's a comment made earlier about the hull overflow, and it was stated that the hull system is from the 19th century, or portions of it are. In early March, I called the staff at the plant at Hull, and I asked them about the system, and it's not a 19th century system. It was built within the last 30 years. I don't remember the date. And that plant is not a combined stormwater sanitary sewer. They told me it was a sanitary sewer only. They've had leaks in the past. This leak was particularly overwhelming to the plant, and that's what caused the plant overflow. That's what the staff at the plant told me. It's a sanitary sewer overflow. There are over 100 of them a day in the United States, according to the EPA. And that plant, if you compare to the proportions, that plant's almost 2 million gallons a day versus the CWP plant that's spec'd out at 640,000 gallons a day. And it overflowed 10 million gallons out onto the beach in front of the plant. And if the same thing were to happen...
Is there a new question coming up? We've covered this ground once before, Jeff. Could you get to a new question or a new topic, please?
We didn't cover the question because we said that it's a 19th century plant. If that plant overflows, then it's a 19th century system and includes stormwater, I'm sorry. And it doesn't. Sorry.
Okay. Now, we've had a response already about we're talking about different locations of plant. One's on the coastline, one's upland, discharging into a groundwater plume. Does anyone on the panel feel they need to elaborate further on this one? No. Okay, thank you. Could I look, here's a hand right down here, thank you, in the white.
Oh, hi. I'm Abby Summersgill, Orleans. I understood...
Speak into the microphone.
Sorry. Oops. I understood that there was an idea that at one point there might be a possible use of the gray water, sanitary water, is that right? Gray water might be used to water the baseball field and other town areas rather than going directly into the marsh. I'm wondering if anybody knows what happened to that idea. It seems like it might be a good one to me.
I think that question will be best answered if you all come back here on May 2nd when you can ask the engineers that one. But perhaps we can give you a partial answer this evening. Brian, do you remember this, any of this?
I think what you're talking about is the potential for wastewater reuse for irrigation.
Yes.
There are 2 ways of dealing with that. You can do surface spray irrigation, which would require a much higher level of treatment in order to allow for that, which translates into extra cost. The other potential would be some sort of subsurface drip irrigation, but it also means transporting from the proposed location out to the various fields that you would be looking to irrigate. I agree with Rich. I think if you come back on the 2nd, the representatives from Wright Pierce can best answer that. But I think in general that was something that was considered, and eventually it was screened out from the recommended plan.
Okay, thanks, Brian. Another question. I see a hand up here in the gray. This Mike's coming to you.
Jim Trainer. With all of the testing that's been done on Namskaket Marsh over the last 30 years, but especially in the last 10, we hear tonight that we don't know where that plume goes, or where the water, what percentage will come up into the marsh, and what percentage will come out into Cape Cod Bay. It seems hard to believe we'll reach this point, and we still don't know where it goes. Where is 500,000 gallons of treated wastewater going to end up, in the bay or in the marsh?
Well, I think we have a pretty good idea. We can go over it again. Brian, do you want to start off?
Let's do this. We gave you 3 options of where it's going to go. We gave you the statements about what the impacts would be, and then really, that's chasing the wrong. If you're chasing nitrogen, you're chasing the wrong thing, because development's going to do a lot more than that, and they're still way, 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 way below your threshold. That being said, when the work was being done in the 90s, late 90s, early 2000s and such, on this marsh, let's just think of what's the possibility that scientists that are doing research on something wouldn't say, we really ought to know where this goes, and we really ought to get some funding to do it. And then what's the chance that if they got that funding, if other people in different groups, and the towns, for instance, thought that that was important, then maybe it would have happened now, and I wouldn't be making that statement, which I'll get heat for tomorrow. The bottom line is that we knew this back then that we didn't know, but the decision was taken because back then it wasn't clear that anything was ever going to happen at Tri-Town. And I think that people were being conservative, what's always a tight money environment. Proposals were written, things were done, and I think some work, Peter's more recent work has come along, other work has come along in that marsh now that's starting to pick it up. But we've said for the last couple of years now, in this room sometimes, you really ought to know where it goes. And that doesn't mean you ought to go out there with well points and do it yourself, but you really ought to know where it goes. So I will turn it back to you. Why haven't you guys done anything?
Peter, do you want to elaborate a little bit more?
Yeah, I just stress the fact that it's a very complex system. From the work we did in the mid-late 90s, we showed that the plume is quite deep. We're talking 50, 60 feet below sea level. And therefore, and there are some real constraints on field work in the area too, because after the bike trail, you're onto private property where access is limited for drilling purposes, the key question, i.e. impacts on Namskaket Creek, where we knew most of the groundwater is coming out, have been the focus of more recent work and of sampling, basically both by the SMAS group and the MEP and also by USGS, to try and be able to say, has there been any change at all since the baseline sampling down in the early to mid-90s. And that question is pretty clear. There's not much doubt about that there hasn't been. So it would be, I guess, of academic interest to, put in 30 more wells or whatever, but it's not really going to change the results of the analysis that Brian laid out before, which has to do with the total maximum daily load that can reasonably be accommodated in Namskaket Creek. So that would be my response.
Good, thank you. Another question in this side of the room now.
I'm Douglas Kosenek from Orleans. As we all know, the proposed sewage treatment plant is not far from Skaket Beach.
Put the mic up close to your mouth, please.
As we all know, the proposed sewage treatment plant is not far from Skaket Beach. So I think we better be damn sure we know where the effluent is going. Also, in the CMP, a review shows that nowhere is there any indication of a clay layer. There's only brief references in Appendix F Phase 8, page 6, section 4, where it makes a reference to, quote, occasional stringers of clay or low permeable silt. Can you explain how, from that reference to the CWFA, we can assume an impervious clay layer?
Okay, worry about Namskaket Beach and also the second part. Peter, you want to start?
Sure. Yeah, in terms of Namskaket Beach, the fact is that, or Skaket Beach, the groundwater flow system in this part of Cape Cod, to the extent that it's characterized, the regional flow system, and this is true along the entire north shore of Cape Cod, that's to say the Cape Cod Bay shoreline. There's a glacial lake deposit, a fine-grained deposit that is quite thick. This is all below the sands that you see at the surface, at the tidal flat sands. And groundwater that originates up near the center of Cape Cod, i.e. along the groundwater divide, for the most part goes under that clay unit. That's what all the regional information shows, and heads out under it, out into Cape Cod Bay at depth. As far as the clay unit around the vicinity of the bike trail, our best information is that we're looking at the sort of feather edge, the inland edge of that larger clay deposit, and it's detectable in all of the wells, all of the borings that were done along the bike trail in roughly the late 1990s. And it's also quite clear that in that vicinity the plume is underneath that roughly 1 to 2 meter thick unit. So that's the status of what we know.
Okay, thank you, Peter. Down front here on this side, in the middle.
Hi, my name is Gail Myers-Lavin, and I may be one of the few people that was here in 1983, whatever it was, when the septic treatment plant was being proposed. I was on the opposite side. I fought the plant with every single fiber of my being. With a lot of other people, we got a report from someone in Woods Hole disputing John Teal's work and so on and so forth. Fast forward, we think that the one impact that we did have was getting a lot of the monitoring wells that were put in as a result of all of the complaints that were made at the time. I guess the question I have is, I've completely turned around. I was on the FinCom as an ex officio member and went to about 18 months worth of wastewater management planning committee meetings. And I completely turned around, and I am now very much in support of the original plan, or at least the original wastewater management plan that we voted. My question, I guess, is, as a lay person who learned far more about septage and sewering than I ever wanted to know, am I correct that these monitoring wells answer a lot of the questions that have been asked and have been being asked, and that you've answered, the panel has answered in a scientific way? But for me, I just feel like the wells have answered a lot of those questions. Could you just tell me if I'm right?
Thank you. I think that's a good question. It starts us to come to a kind of summary of our evening comments. We have just a few more minutes, and I will take time for 1 or 2 more questions. But let's see if we can respond to that question. Have the wells told us enough to give us confidence about some of the plans that are being proposed?
Everything we know today and everything that I said and that Peter said came from knowing, having those wells in and having the studies done. The question that was raised earlier was, well, how come you didn't follow it all the way out to the bay? And the answer was, it takes money to do that, and nobody's willing to fund it. But we know more about this marsh than we know about marsh salt marshes, and it's invaluable. That clay layer alone could be the biggest find for, wastewater disposal in the region. I mean, it's a fantastic thing. If it goes all the way out to the bay, that would be a fantastic thing for the town and for the environment.
Okay, anyone else? Peter, you want to?
Yeah, the wells are one aspect, if you will, of the data that's out there, but it's really multiple lines of evidence. In other words, the fact that there's been extensive sampling in the creek, extensive measurement of the natural groundwater flow into the system. We know where the zones are where groundwater enters the marsh, and the creek itself being the dominant one. And we know from the ecological studies where the plant distribution is on a baseline basis, and also what I think is the most important thing, the overall nitrogen absorptive capacity of the system, which is what the MEP study has focused on. So it's all of those things together.
Okay, thanks. One more question. One down here, and I'll take one more after that.
Thank you, Ken McKissick. I'm sure each of us have heard what we want to hear tonight, one way or the other, but I just want to be clear. From what I understand from the panel is that there is no deleterious effect from putting a treatment plant in that area, even assuming the worst part of the parameters that you establish about where the plume will go. And if the worst part would be the development of Phragmites, I don't quite understand how that is an issue when in fact the amount of fresh water that would be going into that plume on a yearly basis at full capacity, I think would be less than 10% of what we get in rainwater. So I would like to understand.
It's all focused in a certain area, remember. If you sprinkle it over the whole marsh, yeah, fine, but remember it's focused in that one area. But the critical thing is on the frag, that's an issue for the town. Phragmites has ecological value. I mean, people, in Europe, they try to raise it. They'll wipe out other wetlands to bring in frag. So it's not inherently some evil species. The bottom line is it's a question of tolerance. There's not going to be a nitrate thing, there's not going to be a fisheries problem, there's not going to be a problem at Namskaket Beach, there's not going to be any of that, there's not going to be sewage reaching all of a sudden across the railroad tracks and out to the... It's not going to happen. The question is the community have the tolerance for some expansion of the existing Phragmites in that pocket marsh? Yes or no? That's it. That's really the fundamental ecological question. All the rest is for town meeting.
So just to answer the first part of that last question, aside from the Phragmites, is the panel comfortable that based on your conservative estimates and your science and piecing together all the various information that we see no deleterious impacts from any of the plans that have been proposed on Namskaket Marsh? Brian?
I would say that right now, based on the evidence, we believe that this is a sound plan that will not have significant impact on the marsh. That being said, though, please keep in mind that this is a phased plan, that we will be monitoring any activity that may result. I mean, even if Tri-Town stays as it is under the existing groundwater discharge permit, they're still monitoring wells, and that we will be looking at impacts, and should we find that something is different than what we expected, then there is still plenty of time through the phasing aspect of this before it would reach full build-out and full discharge and full flow, to be able to make any mid-course corrections that we may deem necessary as a result of that. So I think it's important to keep in mind that we can always change course should we find the need to do that.
So my last remarks before I ask Doug to come back up and conclude, I said at the outset that I hope we would all leave with a better understanding of the science that underlies the decisions in front of us. I certainly hope you have, and I think you have. I suggested that you think about not taking one strand of the answers or the other, but weave it together so you understand the comprehensive piece, and I believe the panel has done that. And I think you also have a feeling and understanding that this is the best available science and technology that anybody probably has to make this kind of a decision. We're very fortunate to have had these studies and this expertise. So I certainly have some confidence in the answers, and I believe that the last comment that Brian made is an important one. It is an adaptive management process. We'll take one step at a time and see if our assumptions and our studies are valid. We can make adjustments and go forward. And that's the best way to conduct any environmental management solution. So again, thank you to the panel. Thank you for your interest and your good questions. I'm going to turn it back to Doug for one minute.
Well, only about 30 more minutes to go here in my closing remarks. Now, thank you, panel. I know why I was a history major. Science is so complex, but I think you boiled it down for us tonight in the best way you could have done. So thank you. Thank you for your questions. I just want to mention one thing. The question about Hull. That is a big issue and a big question, and we've seen it written up in commentaries and so forth. And it is one that would scare the daylights out of anybody. I will simply say that our consulting engineer also talked to folks at Hull and got a completely different answer than the one they seem to have given Mr. Eagles. So I personally will look into that this week myself with our engineer, and we will have an answer addressing that at the next forum, which will be the one with the engineers. Because somewhere in there's got to be an answer that's accurate. But we thank the panel. If you wish to be added to any of the mailing lists, there are pads in the back, and you can give us your email address, and we'll be glad to add you. We invite you to join us at the next two forums. Thursday, May 2nd is Ask the Professional Engineers, and that's where we'll get an answer on Hull. That's at the old Jailhouse Tavern. And now on Tuesday, May 7th, Ask Our Neighbors, the Chatham experience. We can hear firsthand what a town next to ours has gone through as they've addressed this issue and begun to move forward. So we'll keep the conversation and the dialogue going. Thank you for coming tonight. Let's go home and we'll make Castle by 10 o'clock.